In the last two videos, we've been looking at the binomial expansion for positive integer powers of n. We had the form a plus b to the power of n, and we took n to be a positive whole number. We looked at two different ways that we could find the binomial coefficients. We looked at using Pascal's triangle, and also we looked at the NCR method. Generally, we would use Pascal's triangle if the value of n is small. So 5 or less, we can just go ahead and write those out. If n gets slightly larger, we can use the NCR method. In this video, we're just going to work through a range of different examples and look at using one of the two methods. So let's start off with 1 plus p to the power of 4. So we can see that we've got a positive integer power of n, and that's 4. This is a binomial. A binomial is simply an algebraic expression with two terms. In this particular one, I'm going to use Pascal's triangle now, as we've got a small power of n. So if I'm expanding to the fourth power, I need the fifth row of Pascal's triangle. That fifth row is 1, 4, 6, 4, 1. When we expand this bracket, we're going to have 5 terms. So let's go ahead and do that. So my first coefficient is going to be 1. We're going to have 1 to the power of 4, and then we're going to have p to the power of 0. We always know that these two numbers must be equal to 4. They must equal n. With our values now, the power on 1, that is going to go from 4 to 0, and the power on p is going to go from 0 to 4, or if you like, n to 0 and 0 to n. Let's now go for the next one. So the coefficient is going to be 4. We'll have now 1 to the power of 3, and then we'll have p to the power of 1. The next one will be 6. We'll have 1 to the power of 2. We will have p to the power of 2. Then we'll have now 4. We'll have 1 to the power of 1, and we'll have p to the power of 3. Finally, we will have 1, and then we'll have 1 to the power of 0, and we'll now have p to the power of 4. So we would be expected to tidy this up and write this in ascending powers of p. So here I've got 1 times 1 times 1, which is just 1. I've got 4 times 1 times p, so that's going to be plus 4p. I've got 6 times 1 times p squared, so that's going to be plus 6p squared. I've got 4 times 1 times p cubed, so that's going to be plus 4p cubed. And then finally, I've got 1 times 1 times p to the fourth, which is going to be plus p to the fourth. So there are our 5 terms, and that's a nice straightforward expansion. So all we've done is use Pascal's triangle, and we've now used the fifth row and looked at the coefficients. So that's an example now where we have two positive quantities here. We raise it now to a positive integer. Let's look at the next example, and I'm going to have 2 minus x, and I'm going to raise this now to the fifth power. So at this stage, I could use now the binomial coefficients from Pascal's triangle, or I could use the NCR method. I'm still going to stick with these coefficients, and if we just consider the next row, we've got 1, 5, 10, 10, 5, 1. We always have a 1 on the end, and we can see now that the number below is the sum of these two. So 1 plus 4 is 5. Then we're going to have the next one, which is going to be 4 plus 6, which is 10, 6 plus 4, which is 10, 4 plus 1, which is 5, and 1 on the end. So let's go ahead now and do this. So what we're going to have then is 1. That's the coefficient. We will have now 2 to the power of 5. We're going to have minus x to the power of 0 plus 5 multiplied by 2 to the power of 4. So I'm dropping this down from 5 to 4. I'm going from 5 to 0 on the 2, and I'm going from 0 to 5 on the minus x. This is now going to give me minus x, and we take this to the first power. If the power is an odd power and we have a negative term, this is going to end up being negative. If this is an even power and we have a negative, then it's going to be positive. We do need to be careful when we're expanding with a negative quantity. Plus the next one. So I'm using 10, that's my next coefficient. I've got 2 to the power of 3, then I'm going to have minus x, and we square the bracket. So this, for example, is going to give me a positive x squared. Plus 10, that's a coefficient. 2 to the power of 2, then we're going to have minus x to the power of 3. So I'm always checking, do these two numbers add up to n? Well, n is 5, 5 plus 0, 4 plus 1, 3 plus 2, 2 plus 3, and then our next one, coefficient is 5, we have 2 to the power of 1, and we have minus x now to the power of 4. Finally, we've got 1. We're going to have now 2 to the power of 0, and we'll have minus x to the power now of 5. So go along, check now 2 is descending in terms of its powers, and minus x is ascending. So let's go ahead and tidy this up. What we have here is 2 to the power of 5. That is 32. This is 1 and this is 1. Anything to the 0 power is 1. So we've got now 32. We need to be careful here. This is going to be a minus x. So 2 to the power of 4 is 16. 5 times by 16 is going to give me a total now on there of 80. So what's that going to give us? That's going to give us minus 80x. So let's go ahead and write that. So that's going to be minus 80x. Then this one right here, 2 cubed is 8. 10 times by 8 is going to give me 80. We square the bracket and this will give me plus. So we're going to get plus 80x squared. We now have 10 times by 4. This is 2 squared. 2 squared is 4. 10 times 4 is 40. So we get to now minus as we're cubing the term. So we'll have minus 40x cubed. If we now consider the next one, we've got 5 times by 2, which is going to give me 10. And then we're going to have minus x to the 4th. That's going to give me a positive quantity. So we're going to get plus 10x to the power of 4. Finally, we've got now 2 to the 0, which is 1. We've got 1, and we've got now minus x to the 5th. We've got now an odd power and a negative, therefore it's going to be negative. So that's minus x to the 5th. So that is still using now the binomial coefficients from Pascal's triangle. Okay, let's move on and do another one. Let's say we've got now 1, let's go for something slightly different. Let's say we've got 1 plus x squared, and we'll raise this now to the power of 7, and we want the first 4 terms. So all we'll do is the first 4 terms. So I'm not going to expand this out, as if we expanded it out now, we'd end up with 8 terms. When we have the value of n to be a positive integer, we have n plus 1 terms. So we can now use either Pascal's triangle or the binomial coefficients from the NCR method. Let's just recap now using the NCR method. If we have a plus b to the power of n, we end up now with nc0. We're going to have a to the power of n, b to the power of 0. Now you don't have to write b to the power of 0, as that's just 1, plus then we'll have nc1, we will have a to the power of n minus 1, and we'll have b to the power of 1. We'll go plus dot 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 right up to the last term, and that will be ncn. We will have now a to the power of 0, and then we'll have b to the power of n. So this now gives us our expansion when we have a finite number of terms, and that's when we have n to be a positive integer. Again, you don't have to write a to the 0, you can just leave it as b to the n. So what we're going to do is use now the NCR method. So what we're going to have is the first term, and I'll just write it out here. We only want now the first 4 terms. So the first one is going to be 7c0. We're going to have now 1 to the power of 7, and we're going to have now x squared to the power of 0, plus 7c1. We're going to now have 1 to the power of 6. We will have x squared to the power of 1. The next one is going to be plus 7c2. We're going to get 1 to the power now of 5, and we're going to get x squared, and we need to square this bracket. So we're going to have to use the rules of indices, and be careful. This is often a common mistake made, that we don't end up with x to the 4th. Plus 7c3, that's the next term. We've got 1 to the power now of 4, and we've got x squared, which we need to cube, and we'll have plus dot dot dot, as we know that we're going to have more terms. Okay, so 7c0 should be fairly straightforward. 7c0 is just 1. So what we've got here is 1 times 1 times 1, so we end up now with 1. 7c1 is 7. Now when we looked at the 7c1 in terms of the combinations, we said that this was 7 choose 1. And we could write in general ncr was going to be equal to n factorial over r factorial multiplied by n minus r factorial. And this is what we calculated. So essentially what we got here now is 7 factorial over now 1 factorial multiplied by 6 factorial. And as we can see, 7c1 will give us the same value as 7c6, as these quite clearly are going to be the same. So essentially what we have here is 7 times 6 factorial in the numerator. As we looked at in the last video, 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. Therefore now in the denominator we got 1 factorial and then multiplied by 6 factorial. Clearly they cancel. 7 over 1 factorial is just 7. So what we're going to have then is plus 7, and then we're going to have 1, and then we'll have x squared. Now all I'm doing is simply now just going through these. Sometimes when our value isn't 1 here, we would just do another line of working if it was an exam. Now 7c2, we could work this out manually. So what we've got here is 7 factorial over 2 factorial multiplied by 5 factorial. Again, we can see that 7c2 will be equal to 7c5. These, of course, are symmetric. So what we've got then is 7 times 6 times 5 factorial divided now by 2 factorial, which is just 2 times 1, multiplied by 5 factorial. We can see the 5 factorials cancel, so this is going to give us 42 over 2, which is 21. If I want though, I can just go straight ahead and do that on a calculator. So what we're looking for then is 7c2. We press 7, we hit shift, we don't turn it off, which is the common error, and we hit 2. We can see now that gives us 21. So we get plus 21, and we've got x squared squared, which is going to give us now x to the power of 4. If we now consider 7c3, we have 7 factorial now over 3 factorial multiplied by 4 factorial. You can of course work that out manually, or you can just look at it on the calculator. In an exam you can just go ahead and put that in. So if we take now 7c3, we end up with 35. So we have now plus 35, and then we have x squared raised to the 3rd power, so that will be x to the 6th plus dot dot dot, and that gives us now the first 4 terms in the expansion of 1 plus x squared to the power of 7. Okay, let's do another one. Let's go for 3, and let's really push the boat out here, minus 1/2 x, and we'll raise this now to the power, let's go for the power of 10, and we want now up to and including the terms in x to the 4th. So what we'll go to terms in x to the 4th. Now with this one, quite clearly, you're going to want to use the NCR method. Finding the 11th row of Pascal's triangle and applying that is quite tedious. So what I'm going to do is just go ahead and write it out. So what we're going to have then is 10c0. We're going to have 3 to the power of 10. We'll have now minus 1/2 x to the power of 0. Plus 10c1. We're going to have 3 to the power now of 9. And we'll have minus x, 1/2 x to the power of 1. Now we're taking this to the 4th power. In later videos we'll look at an alternative way of using a binomial expansion, and that's the method of 1 plus ax to the n. With this one, as this value isn't 1, I would use the approach that we've been doing. But with the method of 1 plus ax to the n, we can expand any rational value of n, and we'll look at that as stated in a later video. For now though, all I'm going to do is go ahead and expand this. So what we want then is the term now up to and included that in x to the 4th. So we need now 10c2. We're going to have now 3 to the power of 8, and we'll have minus 1/2, and we have x, and we need to square this. Plus the next term, which is going to be 10c3. We're going to have now 3 to the power of 7. We'll have minus 1/2 x to the power now of 3. So what we're looking at then, these two numbers are always going to be equal to n, and we can see now that the second term, the number corresponds to the number we have at the bottom. So plus now, the next one is going to be 10c4. 10c4, let's write that correctly. We're going to have 3 to the power of 6, and then we're going to have minus 1/2 x to the power of 4. plus dot dot dot, and so on and so forth. So if we expanded this out fully, we're going to have 11 terms. I only need the first 5. That is up to and including the term in x to the 4th, because this is simply going to give me a constant. So what we have here now is 10c0, and that is going to be 1. Then we've got now 3 to the power of 10. So let's go ahead and work that out. So 3 to the power of 10, this is going to get quite big. It's pretty big. That's 30 to the power of 10, which is slightly, there we go, 59049. So we've got 59049, and that, of course, is just going to give us 1, plus 10c1. We should automatically recognise this as 10. Then what we're going to get here now is 3 to the power of 9. So if we think about 3 to the power of 9, we can go ahead and put that in, and we're going to end up now with 19683. So let's put that in, 19683. Now what we're going to have here is minus 1/2 x. What I'm going to do is gradually tidy this up as I go. But what I want to do here is just consider now what we're going to have in terms of these powers. So don't be scared to write a couple of lines out rather than going straight at it. Now we've got 10c2. So if you want to do that in the calculator, you can grab that up. 10 shift, then the NCR button, 2, and that gives us now 45. So what we've got now is 45. That gives me the coefficient. We've got 3 to the power of 8, so let's do 3 to the power of 8, and that's going to give me 6561. So 65, and then we can have 61. We need to square this. This is going to give me 1/4 x squared. As we saw in the last example, if we have now a negative number in here and an even power, this will become positive. Plus, the next one is going to be 10c3. So we can put 10c3 in the calculator if we like, or we can work it out manually. I suggest in an exam you just work them out as you go. That's 120. So we're going to have now 120. We're going to multiply this now by 3 to the power of 7. So we need to be accurate with our working in this particular example, and that's 2187. So 2187, and then this is going to be now, so we're going to now cube this term. This is going to be minus 1/8 x cubed. So when we cube minus 1/2, we're going to get minus 1/8. And then finally, we're going to have now 10c4. So if we look at 10c4, let's put that in, 10 shift NCR button 4. That's going to give us now 210. So that's the coefficient. And again, if we'd found that with Pascal's triangle, that's what we'd end up with. Now we need 3 to the power of 6, which is what, 729. Let's do that. 3 to the power of 6, 729. So we get 729. Now we're going to get this term raised to the 4th power. That's going to be positive 1/16 x to the power of 4. So all we need to do is go ahead and tidy this up. So I'm going to have now 59049. That's my first term. That's independent now of x. So that's just a constant. What we're going to have here, and let's go ahead and just plug it into the calculator. I suppose we could make this slightly easier. We could just say that this is going to be minus 5 multiplied by this quantity. So let's go and do that. Let's do 5. So 5 times by the 19, so 19683. As you can see, accuracy is really quite important in this particular topic. So that's going to give us 98415. So minus 98415x. Let's now look at this one right here. So let's go ahead and do that. We're just going to plug this in the calculator. We're going to have 45, and that's going to be 45 times by 6561. We're going to divide this now by 4, and it will be now a positive term. So let's check that all looks good, and that's going to give us now this quantity right here, 295245. So we've got 295245, and that was over 2. We could, of course, write that over 4. We could write that as a decimal answer, but we'll just write it anyway, and that's going to give us now the term in x squared. Let's go ahead and do this one right here. So we've got now in the numerator 120 times 8, 7, and then we're going to divide this now by 8. I suppose you could have tidied that up initially, and that's going to give us 32,805, and that's going to be negative. So 32,805 x cubed. So let's go ahead and check that. Again, the accuracy is quite important here, especially if you're doing approximations later on, and we will look at some of those as we go. Okay, let's now look at the last one. So what we have now is 210 multiplied now by 729, and then we're going to divide this by 16. So that is going to give me now 76545 over 8. So we've got to now 76545 over 8, and that's a positive term, and that's x to the 4th plus dot dot dot, and so on and so forth. So what we've got here, let's just check that I've put that in, and that looks pretty good. So what we've just done there is quite a nasty expansion. It's highly unlikely you would get anything that has such large numbers, or the magnitude of the numbers being so huge and so fiddly in an exam. The idea of that particular one was just to go through one where you have to keep on top of things. We only wanted the terms up to and including that in x squared. So I've expanded now the bracket to the first 5 terms. We've considered the coefficients. We've looked at what happens if we have a negative and an odd power, and a negative and an even power, and then tidied it up. Well, I say tidied it up at the end to end up now with this rather nasty little list of numbers. Again, we've got now x to the 0, x to the first, x squared, x cubed, and x to the 4th. Okay, so hopefully that's given you some idea on the 2 different approaches you could use for this particular method. It's either using Pascal's triangle to find the binomial coefficients, or the method of NCR. If you need any help on those 2 methods, please do check out the 2 videos prior to this.